Hello, this is Joseph Miles, and this is my presentation for the reconstruction of the MIMIC3 database for data analytics at SUNY Oswego. So as a little introduction, the MIMIC3 database is a comprehensive collection of de-identified data from 53,423 distinct critical care hospital admissions from 38,597 distinct adult patients. Some of those numbers seem to have changed a little bit, so we'll say at least that number. I believe there may have been more added since then after I've looked at this database more in depth. The data comes from Beth Israel Deaconess Medical Center in Boston, Massachusetts. Everything, all the information is held by the Massachusetts Institute of Technology, MIT, and they are who I went to acquire the 26 tables, which contain, as it says there, 324 different columns or attributes within this database. Just as a point of statistics to get a feeling of how massive this database is, there's an average of 4,579 charted observations and 380 laboratory measurements for each hospital admission. Some patients are admitted more than once, so this is even beyond each patient, so this is each admission. And as another thing to think about is that this database contains over 2 million rows of unstructured textual data that is just from various healthcare providers, their analysis and synopsis of what's going on with the patient. And the file is absolutely massive, gigabytes of information that is just text information that was written by the provider. This is an interesting diagram that came from the people that have put together the MIMIC3 database, just to show where all the information came from. They do have one external source noted here, Social Security Death Index, to track which patients died that are in the database, so they could include that information as accurately as possible. And then it all goes into this data archive, which really is in the context of data analysis, a data warehouse. And there is a little bit of update, but for the most part it's a static database that you can see constructed in this diagram. So the main users of this database are going to be researchers and data analysts at SUNY Oswego. Different outcomes that would be expected from the user would be project creations, project validations, and really to sum up, all of these things all would fall under the umbrella of data mining exercises, especially, as I noted before, when you have so much non-structured, unstructured textual data, there is a lot of room for analysis and things to cut our teeth on. The overview of what needed to be done for this project is, after getting permission from MIT that I would protect the patient data that's in there, even though it's de-identified, I still had to go through a process of being trained for using patient data. So after downloading all the data, which was, if I remember correctly, over 40 gigabytes of just raw data. So once that was acquired, implementation happened in 5 additional steps. That was to use SQL code to create the tables, use the different business rules for the data, as I found from reverse engineering the MIMIC3 database, and then identifying primary keys for each of the tables and putting that into the SQL code, which was interestingly completely missing. The SQL code that was previously used, that was available through MIT, used unique keys in the same fashion as a primary key, but not in the same way that I would have done it. And we may see that later on in this presentation. Then the second part of the process is then to load the comma separated values file for each of the tables. That's 26 different files that were loaded into the database. After that was loaded, then I declared the indexes for each table. I initially tried to declare the indexes first, but that became a very time-consuming process to load the data after the indexes were declared. So I aborted that and then reversed those two steps, and then defined the foreign keys and then established the relationships between all the different tables. Then the last step was to implement the user interface using a PHP program. Used the heart of it was something that I downloaded, I'll discuss later, and then I changed it for this particular instantiation of the Mimic3 database. So as far as the conceptual data model, this was, I would say, more than half of the work that was done for this was all in creating the conceptual data model, which is remarkable because there is a lot of conceptual information that already exists out there, but it's such a large database, and there were little nuances between the different interpretations and previous instantiations of Mimic3 that it was sort of going through and picking and choosing for each attribute which definitions I agreed with. So the initial data dictionary, as you can see here, this is a publicly viewable website here, and this is one of the tables, the admissions table, and this is what they give you. Their suggested database management system is PostgreSQL, and so on here they give the data types if you are using PostgreSQL, and in this particular case I'm not, so there was a little bit of interpretation needed here, but this is all that they gave you. There's nothing as far as suggested indexes. There is at the top a listing of where this table links to other tables. So going through each of the tables and interpreting that information, I found where links needed to go, which ended up being very important because from previous code, there were some of these linkages that were intended from the makers of the Mimic database that didn't seem to be put into effect in actual instantiations. There are 3 cases that were explained from feedback that I read from previous people that had worked with this database, but the rest didn't have an explanation. Some of the nuance that I referred to earlier comes down here. The admissions table defines all HADM ID present in the database, covering an admission period between 1 June 2001 and 10 October 2012. For me, I interpreted that fairly clearly that the HADM ID is and should be the primary key of this particular table. However, in the supplied SQL code for both PostgreSQL as well as MySQL, they chose to use this row ID, which is also a unique ID, but they use that as the primary key of each of these tables. Each of the 26 tables does have a unique row ID number. However, fairly clearly in 9 of those tables, that row ID column is actually completely unnecessary. So I made sure not to refer to it in any of the SQL code that I used for the SUNY Oswego instantiation of this database. So from here, the I created the entity relationship class diagram because of the number of different columns in this database. I chose to only mention primary keys and foreign keys in the ER class diagram that I created. I have used alternate coloring for the headings of the parent tables. As you can see, there are 6 of the parent tables here, showing their linkages with all the child tables. I chose to use the designation for 0 or more in the one-to-many relationship because it was hard for me to characterize which of these tables always had information in the child table and which didn't. So I erred on the side of showing 0 except for the admissions table, which I knew every single patient, every single subject ID is tied to at least one entry in the admissions table. I had mentioned that there were 3 cases where links didn't previously exist and still will not exist in the SUNY Oswego instantiation, and that's for these 3 parent tables here, because the foreign keys that are used in these 3 particular tables, the CPT events, diagnosis ICD, and procedures ICD, there's not exact syntax used. So a lot of those keys didn't match up with the primary key in the 3 parent tables in the bottom left here, noted with the red. Red was used intentionally to show that they are just not linked. So they are in the database. The data is there. It could be searched through. But the relationships are not enforced. They're drawn here, and that's why they're in dashed lines with dots between. These other dashed lines over here are the ones that were not included in previous instantiations, and at least as can be derived from SQL code that's on MIT's GitHub site. But these do exist in the SUNY Oswego instantiation. I'm sure they exist in other people's instantiations too, but they just weren't mentioned anywhere, so I made sure to add those in. Particularly interesting is this microbiology events table in the bottom right has 3 separate item IDs that all refer to the same table listed at the top here, this D_items table. So that was kind of a unique relationship where there are 3 foreign keys referring to the same parent, which MySQL seems to handle very well. When I tried this out on Microsoft Access, it did not like 3 foreign keys at all. So just something that I found in my playing around with this so from there, the entity relationship diagram was part of it. At least as much time was spent on creating a data dictionary. The data dictionary, to fast forward to the end of this is the data dictionary that was created by phpMyAdmin. So in my local test environment that I created for creating the Mimic3 database locally, I had it analyzed by phpMyAdmin, and so I got to compare what they show here and the links that were created to ensure that they matched my particular data dictionary, which can also be seen. There's a link at the top here, and this may take a couple seconds to load because it is fairly large. Again, I forget the exact number of columns that I mentioned earlier, but it's a lot. Table of contents here. listing the different tables which you can click on, and it will bring you to that particular table and each of the attributes, along with whether it's primary key, foreign key, not null, whether it's indexed by MySQL, and then there's a description of the table itself in bold here, and everything up below is a description of the attribute if I was able to find it. There are some blank ones in this table, not too many, just a few, that I wasn't able to find a specific description of what the data is. So this is available online. The website up here is a live website containing this data. Unfortunately, at the time of this recording, I don't have the Mimic database installed in a place that's accessible to show beyond my local environment here. So we'll be able to show that in a couple of minutes as we get there. So that's the data dictionary that I created, and then previously the phpMyAdmin data dictionary. The use of this database, I didn't go so far as to create a whole use case, because it's simply outlined here is that the researcher data analyst would be the sole actor on this environment, is going to use ad hoc SQL interface to pull data from the database, and it will be implemented as read-only. Given the nature of what this is, there shouldn't be any day-to-day need for inserting data, or in the realm of creation, read, update, delete. There should also not be updating or deleting of information either. So it was created read-only. This is a screenshot of the actual interface. So I can pull this interface up. And again, it's a local address here. Computer that's just in another room in my home where I'm recording this right now. So this does accept anything that's a select command. In MySQL, there's select, show, describe, and there are a couple aliases used for describe that will also accept. So I'll show off a little bit of the usage of this. So you have show tables. Here's a listing of all the tables that were loaded into the system. One of the things that I added to this interface, which I did acquire, I have down here, adapted from the original SID design by Bill Weinman, and his copyright information down here. For the most part, this interface is largely his code that I have just modified for the purposes of interacting with Mimic 3. And one of the things that I added was, because some of this data, when you're talking about millions of rows, it made it a lot nicer to use row striping as far as colors to find where, and I also added the code to yellow highlight which rows we're looking at as we go down. So for here, it doesn't make a big difference, but just things to show that were added to the interface for a little bit nicer usability. So beyond show, and before we get into various select commands, then we can do describe as well. So we'll describe the admissions table and click process. Enter doesn't process because, as you'll see later, we will add multiple lines of code. So character turn in the interface just allows for more code to be added, which is going to be a lot nicer as our code gets more intricate. So again, this is the admissions table. As I described earlier, using the admission ID, which is unique, as the primary key, I have relieved MySQL from paying any attention whatsoever to the row ID field. So it doesn't matter if for some reason there was a non-unique piece of information in there. It exists, it's there. If for some reason we needed to find a piece of information by row ID, we could. It would take a little bit longer because it's not indexed, but I can't see any reason why a generated row ID number would be interesting to anybody. So I've kind of taken the wind out of the sails of row ID. So there's described the admissions table. So now to show what I was talking about as far as running multiple queries, we can have these pre-typed here. So now we're looking at the note events. Note events is a pretty interesting table. So we have describe, is the describe, and then we have show, and as you can see, different syntax used actually comes up with the same exact results. And then we have the show keys, which down here shows which fields are indexed. Because the row ID is in this particular table the unique key. This one is unfortunately tracked by MySQL. I say unfortunately because it's largely useless information, but it is what makes each row unique for this particular table. So note events, as I said, is interesting because this is the one that contains the text data, and in the realm of data analysis, analyzing text is pretty cool stuff. So up here, you'll note that I'm including a limit of 5 because I don't want to pull up millions of results. So we'll just show the first 5, and this is what we have in each column. We have a text, and this is one record that is still going, still going, still going, still going. So there's a lot of text for each entry. Not sure what that green box was. Just an artifact. But what is interesting, one of the things, this is the halfway point. So here we can see which patient this is linked to. But what is interesting is having an interface through a browser like this. All this data is copyable and paste into another document. So as far as extracting this information and plugging it into some other utility for analysis, it is literally cut and paste. So we can see from the highlight, we've jumped to the second record. So this is just record 2 of 5, and there are 3 more down below. So one of the things that I did once we got this up and running, to verify my one or more relationship that I discussed earlier on the ER class diagram, I could verify that here by looking at how many distinct patients there were, and 46,520, and distinct subject IDs mentioned in the admissions matches the 46,520, which, as I pointed out at the beginning, is a larger number than what I said at the beginning of the presentation as far as my introduction to this database. So I'm not sure if there's extra people that were added. I know in particular they mention adult patients, and there are neonates as well, but even factoring in the neonates, it seems as though there's a different number of total patients mentioned, but all in all, a lot of data to analyze. And to show this further, I can add in analysis of the call-out table, which is a table of patients being moved from ICU to a different department or being discharged. As we can see, there are not as many subjects mentioned in this table as there are overall subjects, which is part of the reason I used the 0 or many in the entity relationship. But we can see that play out in these various tables. So to get a little bit more interesting with this, now we're going to add a couple more things to look at. So we can, from this query, we can find how many patients mentioned in the MIMIC3 database have passed away, have expired. They list 15,759 and 30,761 as far as they could tell from verifying with the Social Security database, had not passed away on this snapshot. Beyond that, as I said, that I did practice a little bit of cut and paste to make sure that data was interpreted well from this interface. So using this select statement, I came up with these results. So date of birth, admit time, and whether or not and copy some of this information, not all of it, but I do an Excel spread, and nicely actually the structure Excel pretty flat. I could plug in a of the date of birth. There are a couple of the neonate, but in the from HIPAA, somebody is over the age of 89, you can't specify because it's easier to figure out who, because there aren't as many people in their 90s. Somebody age 92 is admitted to a particular hospital. We pretty easy who that person is. For this of 3, the date of birth that was 300-year admit date. The other thing to note here is that all of the dates have been transferred future. When they transformed, they did preserve the day of the week that dates will take place on. They also preserved the approximate season of the year, but other than that, you can't tell anything. This particular date that would let you know when this patient was actually admitted to this particular. But as you can see, Excel on this date of birth thing, at least the way that it copied and pasted here. I looked at this a little bit. Obvious way to fix this. However, I'm just using to do the work. You can just SQL. So here's another, as far as there's so much information on here. You can see there are 50,976 rows. So as of right now, my computer is struggling mightily to deal with that. So let's move to search. And in this particular select command, we have the date and ages being interpreted by SQL instead of relying on an outside source. So let's process this at the 20. So this will give my computer a break here. The reason I did this is to show specifically in Excel where Excel just gave up and gave an error message. We show here the 300 or older age represented for each of these admits. And beyond that, there was a really long select command proposed by the makers of this database to test things out. And so this was the last trial that I performed on my test instantiation of Mimic 3. It will soon become the SUNY Oswego instantiation. And so this particular set I have I've switched to descending for the age group to show that we do have a wealth of neonates in this database as well, which can all be parsed out. Pre-ICU length of stay was the column of interest in this particular select command to see how long they were in the hospital before they were admitted into the ICU. Of course, we can put that in the order by clause and look at that a number of different ways. So that's the interface and a bunch of different queries used. So to sum this up, this is the goal of informatics. As much as informatics is the combination of the efforts of a human user and technology together to outperform each of the human and the technology by themselves. This is the goal of informatics, and in particular health informatics. We're looking at using data as we find in Mimic 3 to create information and find better knowledge that we can apply towards wisdom for future success. So this is the written out version of what I just said, and that future success for health informatics will be in producing wisdom for improved patient care in the era of evidence-based medicine. What better evidence do we have than millions of rows of data that can be put together to find trends, and at the very least will lead to better research and better informed practitioners leading to better care. So beyond the hope that medical wisdom can be derived from the multiple instantiations of Mimic databases utilized around the world, hopefully the existence of the Mimic database and the success it continues to create for those who utilize the data's information will lead other institutions to similarly share and utilize patient data towards the goal of increasing patient care wisdom. So thank you for listening to this presentation and watching the interface to see a glimpse of the interesting things that we can do with this data. These are the references that I used in this particular presentation. I do have a more in-depth write-up of this, which you can request from the email that I had posted on the first slide. I would like to particularly mention Bill Weinman. Again, it was his PHP code that I used for the heart of what that interface is. In some ways, I had to neutralize what his did. His had the functionality to change databases and do more as far as inserting data and transforming data. But I sort of took all that functionality away from his interface to make this more particular for what our uses are. So again, to leave you on the first slide, that's my information. I'm Joseph Miles. My email address is jmiles3@oswego.edu. Thank you very much.